little bit of what we learned in our last unit combined with probability. So find the probability that a random point on this figure is in the shaded region. Write your answer as a percent rounded to the nearest hundredth. So let's talk about a strategy. Remember, probability was success over total. So our desired outcome is to get in the shaded region. So I need to find that area. And on my denominator, I need to put the total area. So here's a strategy. Let's plan the area of the square minus the area of the circle. That's going to give us the shaded part. So the square is 22 squared, which is 484 square meters, minus the circle. Well, if the side of the square is 22, what's the radius of our circle? That'd be 11. So pi times 11 squared is 121 pi. And for this one, since we're rounding to the nearest hundredth, we need a decimal. So we multiplied pi, the button on the calculator, times 121. So 103.87 is the area of the shaded region. So remember, we needed the shaded part over the total. So our total area of the square was 484. So 103.87 divided by 484 gives us 0.2146. Let's write that as a percent. Easy way to do that is to just move the decimal over twice or multiply by 100 and get 21.46%. 21.46% chance that a random point selected lies in the shaded region. Find the probability that a random point in this figure is in the shaded region. So same directions about rounding. So we're going to do the total area, and then we need to find the shaded part to put on our numerator. So strategy, area of the rectangle minus the triangle. So here we go. Well, the rectangle is 16 times 18. Length times width, that's 288. Now let's talk about the triangle. The triangle is 16 times 12 divided by 2. First of all, where'd the 16 come from? That's the height of the triangle. How did we get 12 for this base? I'm thinking we did the Pythagorean theorem because I know the hypotenuse is 20 and one of the legs is 16. So 16 squared plus b squared equals 20 squared. That's how we got 12. So the area of the triangle is 96. So the shaded region is 288 minus 96, which is 192. That's our numerator. That's our desired outcome. And we're going to divide by the total area, which we already found is 288. So put that in your calculator and you get 0.6667. When you multiply by 100, you get the percent, which is 66.67%. All right, let's do another one. Find the problem that a random point on the figure is in the shaded region. Okay. Well, let's think about how we're going to find the area. We have to do the rectangle minus 6 circles to get our shaded part. Well, I know that this is 30, so what is the length of the rectangle? Well, if the height is 30, what's the diameter of each circle? I think it's 10, which means the length of my rectangle would be 20. So 30 times 20 is 600. That's the whole rectangle. Now let's think about the circles. If the diameter of the circle is 10, what is the radius? That would be 5. So I have 6 circles at pi times 5 squared. So that's 25 pi. Again, we're going to put it in the calculator because we want the decimal that we're going to round off, and there were 6 of those. So that's 471.24. So we do that subtraction. 600 minus 471.24 gives us 128.76 for our shaded area. Remember, shaded over total, 128.76 over 600. We get our decimal. We multiply our decimal times 100 to get 21.46% chance that a random point selected lies in the shaded region. So try these and see how you do. So pause the video, try these three, see if you get the same answer that I do. The first one is a trapezoid, and I'm going to subtract. I'm just going to find the area of the trapezoid, and that'll be my total. And on the numerator, I'm going to put the rectangle, which was 40, over the area of my trapezoid, which should have been 70. That was number 2. Let's go to number 1 now. This is another circle one. If you look carefully, you've got 2 complete circles, and we have our rectangle. So if the diameter of one circle is 10, then the length of my rectangle is 20. So my denominator is going to be 200. And I've got 2 circles, each with a radius of 5. So that's going to be 50 pi. And you should come up with an answer that's 78.54. And then number 3, we have kind of a target with 2 circles. So let's find the area of the big circle. And then the area of the little circle will go on the numerator. So you should get something like 16%. So now you're going to do your practice for geometric probability.